Check, check, check. I think we're working. Hello, hello. Hello, hello. Hey, Andy. Excuse me, my voice is my voice is still not very good. Welcome, welcome. I wanted to follow up on this power supply. Hello. I wanted to follow up on this power supply. Welcome, welcome. Are you all watching Joey also? Welcome, welcome. Hang on a second. Okay. Oh, you're not watching him? Okay. Anyway, what he's talking about is soldering iron. There's Russ. I know Russ is over there. I saw you over there. All right. I think the power supply is fixed. And I wanted to go over with you what I had done. Let me show you its functionality at the moment, if I could. And some of you could, some people want to watch it later on. 5 amps, and I'm going to crank it up to 10 amps. Watch the PFC boost voltage. 13, we're approaching that critical 16, 15, 16, rock solid. 17, 18, 19, 20, keep on going. 21, 25, we're rock solid. 30 amps, 31 amps, that's as high as I'm going to go with it. It might go a little higher, but we're solid. I'll put it back. There's that 16 amps that I like to go crazy on. We're good. Now, what was it? Hello. Yeah, people are coming in. I don't see him in the chat now, but it was Orion. I don't remember. I have to look at his full name. Orion led me in the right direction. Orion 310591RS. Let me shut this thing off. Shut it off. Let's make it safe. I'll try to get in the habit of doing this, because otherwise I will get bit. I don't like getting bit. All right. Let's see. Let me look. Just a moment. I think I'm going crazy. I think I am going crazy. Nope, I am crazy. Well, shoot. Well, never mind. I have messed up. And I have confused myself. I've got my power supplies mixed up. This is my good one. So, yeah, I do not have it fixed. This one, the opto isolator had been swapped on it, and it was the wrong one. I don't remember doing that. But it had the wrong opto isolator in it for the feedback voltage. It had this 1004 in there. Well, shoot. Yeah, this is the wrong one. I just realized, I saw that check mark. Wait a minute, that's not the right one. Let's get the other one back out. I have played myself. Yep. I have fooled myself. Let's see what this is doing now. I'm pretty sure we're back in the same boat on this one. Let's find out. All right, 5 amps, 395. $10, $11. There we go, 15. No, we're right back where we were. And I got my power supplies mixed up. I apologize. You hate when that happens. 415. And bouncing around. Unplug it. I was ready to be through with this thing. And move on to something else. Because these, I may swap it, but these opto isolators look to be the original. They have not been messed with. And I doubt that's the problem. They are the originals. Well, shoot. Well, I thought I had a good update for you guys. Yes, this is one of the ones from Roy. Had a lot of components missing. And I thought that I had it fixed, but I got my supplies mixed up. Which is why I mark them, so I hopefully won't do that. I've cleaned this board, though. I scrubbed it because it had junk all over the board. And I got to thinking about, well, maybe there's some leakage going on. And some of these, some of the circuits, we're talking, 10 megohm resistors, 4.7 megohm, 7.5 megohm resistors. Wouldn't take much to upset things. Those are the originals. I have not changed out this DNP014. I just don't think it's anything to do with it. I really don't. This is on the cold side. Handles a lot of the shutdown. Over voltage, over current on the output side. Controls the feedback for the voltage correction. Drives that opto isolator. And I have looked all over this board, haven't found anything. It's not shutting down. I thought about lifting the shutdown controls, but it's not really shutting down. This is frustrating. Well, thank you, Law Dog. Excuse me, my voice is starting to fail on me again. Thought I had this one fixed. Isolating the feedback worms. I'm not sure how I would do that. I don't think it's anything on the output side. And I hate to just I hate to just start swapping parts. I don't like doing that. But that's what we are approaching, is just swapping parts until we see it, act right. I am wondering about this PFC coil. It seemed like it was making an audible noise. At certain loads. Everything looks clean. I have not swapped out this chip again. That's a brand new DAP053. I could put a 2016 on there, but it isn't going to give you as much current. It'll run, it won't give you as much current. The other option was to sit here and make comparisons forever. It's very time consuming. Using my little circuit well, what's the proper term I'm looking for? using this. I think I'd have to be very lucky though to hit something. Have to be very lucky. Well, to be able to see, this lets you compare, you know, identical circuits. That's what it's intended for. It's a two-channel device, so you can make comparisons between a working and a non-working, you know, and look for subtle, because it'll, you know, capacitance will show up as a circle, and hey, Steve, good to see you. No, not oscilloscope. I can't remember what you call them. What do they call these? Curve tracer. That's the word I was looking for, was curve tracer. Let me get this thing out of the way. Let me get that off the screen. What the heck? We'll give it a look. I'm afraid that whatever this is too subtle. All right. Working board with a check box there, check mark. Non-working board. Make absolutely sure that we are discharged. And I will short them again. Not much there. But I want 0 there. All right, which channel do I have here? Oh, and I need dual channel. Okay. That's the red channel. I'll see if I can get that in the shot here. I'm sorry. Maybe. I kind of need an angle where I can see it. If you know what I mean. Okay. All righty. Which channel is it? This is the yellow channel. All right. Can we make some comparisons or not? Oh, this tracer I'm using, Steve. Yeah, this is a modern one. It's pretty neat. It's debatable, I guess, how useful. It came from Turkey. Microcore Electronics, I think it is. The website is Ucore Electronics, I think it is. What is the model of it? I can't remember. It's like a 330 or 320. but it's kind of neat because it is a dual channel one. So you can put a probe there. See that conduction curve, and this red one, and it will overlay them, and it'll give you a percentage difference. It shows 0.7% difference. That's looking at pin 1 of that chip. So, and you can tweak some, like how much voltage it's putting out and that kind of stuff. So, and there's pin 2. It looks identical. See that nice little knee curve it has there? Pin 3. Difference of 0.3%, identical curves. Pin 4 is ground. Let's go to pin 5. Nice little curve, difference of 1%. Pin 6. 1.3%, identical curves. Pin 7. Is no connection. Pin 8. Okay, we have a capacitor there. You can see on pin 8. See that? You get that circular pattern. You know, it says there's 5 microfarad there. Of course, there's probably a lot of stuff in parallel on that circuit, but you can see a circular pattern on both of them. And it's the exact same pattern. So it's the same capacitance. So identical, what it should be. All right, let me see if I can get on pin 9. Yeah, there's a capacitor charging up there, but yeah, that's the same pattern. The same, pin 10. Beautiful. 11. 1% difference, same. I don't think we need 12. 13. A circle there. Shows 40-something microfarad. That 13 is the supply into this chip. So there's going to be a good bit of capacitance there. But identical. And 14. Am I on the right? 14, yeah. 0.8% difference. Shows there's a 15-volt Zener on that line. And this is 15. 2%. 16. 0.8%. So, identical. That's identical. Good morning. Okay, I'll send you a link to it. I'm not sure. Yeah, maybe they still make this model, but they know they may make a newer model. I've had this one about 2 years. It had a problem when one of the channels didn't work when I got it, and I had to open it up and had some bad soldering. You know, where they had floated on one of the inputs. And I sent pictures to the company, and anyway, they apologized, but I didn't want to send it back to Turkey, so I just fixed it myself. And they said, yeah, they offered me a discount if I wanted to buy something else from them. That was years ago. It's probably long since expired, but anyway, they were friendly about it. But it wasn't practical to send it back. But it's been fine ever since I touched up those solder connections. I'm going to look at some of these. A lot of capacitance there. You got a big old circle, but otherwise the same. There's a smaller circle. See a capacitor charging up. And the idea of this is that it gives you visually, you know, a way of comparing circuits. Not just simple diode readings. You can actually see, you know, the curve, the conduction curve in positive and negative, because it's applying a sine wave is what it's doing. And which you can adjust. I think it's got a couple of different levels, but I think it's up to 20 volts. So you can actually see things breaking over, conducting in both directions. So it has its uses. Honestly, I can't. I don't think I can say it's helped me fix anything yet, but it looked like a very useful tool, so I got it. But so far, still nothing is jumping out at me. Maybe we should focus our attention in the PFC area, but this is on the PFC transistor. I believe that is going to be the source. I mean, they're identical. I get the exact same waveform, exact same conduction pattern. I'm not sure how well, is that showing up on camera? Sorry. It's kind of a small screen, I guess. But it's kind of a neat product. Now, how useful is it? I don't know. But a very neat product. And I would love to tell you that it's helped me fix so many things, but I really can't. But then again, maybe I have not, broken it out at the appropriate time. But it would let you, visually see. And I think they have a version. Yeah, I think that this is something the U-Core, Microcore, whatever, has a version you can hook to a laptop and capture the images. And anyway, it's kind of neat. It's not cheap though. They do like their stuff. But yeah, it's just some pattern comparison is what it is. But it's putting out, I think it's, I don't know what I got it set for. It's putting out a sine wave and just showing you the conduction characteristics of it. And if you have two identical circuits, something should, if there's a problem, something should jump out at you, in theory. In theory. Nothing has jumped out at me. This is just going to be one of those faults that's rather subtle, I think. And this could be a transformer issue, which is probably my next step, is to be to swap out, say the PFC coil, not a transformer, the coil, swap it out between these two boards. What happens? I mean, it looks identical. So far, I haven't done anything on the cold side yet over here. Anyway, let me see what's going on in chat over here. Oh, another member. Thank you. Is it King Nothing? You use it all the time, to be fair. Yeah, the connections look good. The faulty one is down here. The one with the check mark is the good one. And I got them mixed up, and I thought I had this fixed, and I did not. So basically, the red trace is going to be the faulty one. The yellow trace is going to be the good one. And now, Steve, I don't know I streamed the repair on this thing yesterday, and see, I don't think you were in chat then, but I can catch up on what it was doing. It was missing several parts. This was given to me by another gentleman on YouTube named Roy, and it's a 400FR. It was missing the switching MOSFETs for the 12 volt. It was the fuse was removed, the 0.1 ohm resistor. It looked like someone had just stolen the parts off of it. So I reinstalled those parts, I didn't replace the DAP053 to begin with. I just fired it up and it ran, but it gets unstable. The PFC voltage is stable until you hit about 16 amps of current draw on the load. About 16 amps, and suddenly you see the PFC voltage hitting 415. Oh, I also replaced the bulk filter capacitors. They were both swollen. The big, I think it's 150 micron. They were both swollen. The ends had popped. But it runs, it works. The 12 volt output is stable, but the PFC voltage around 16 amps will just get wild watching it on the meter. I've seen 415 and it just goes random stuff. So it works fine, except at, certain loads, up to 16 amps of load. The PFC voltage is fine. It just gets unhappy. And after that, after I saw that instability, I changed out the controller to another DAP053. This is not the TEA 2016, so it's an identical chip. And that did nothing. It still runs the same. It still gets unhappy. It doesn't shut down. It's working. But compared to this known good board here, which is rock solid, the PFC voltage doesn't do that at all as you ramp up the current. So yeah, that's where we are. Unstable PFC voltage. And it seemed like once you got beyond 16, 17 amps, it would settle back down again, but then later on in the 30 amp range, it would start getting unstable again. So it's that kind of a fault. Not a hard fault. Not a I'm not going to work fault. It's just I'm going to be weird fault. I'm going to look around this DMP014. Because I have not looked on the cold side of this thing at all. I just don't think I'm going to find anything. Yep, that's identical. That's pin 1 of the DMP014. I'll go to pin 2. Slight difference. 10%. There may be a little bit of charge. Let me short the 12 volt terminals. Just in case a little bit of voltage, a little DC setting on there, because it will skew things a little different. What does it get now? Now 2.5% difference. Okay, pin 3. It says 7.5%. Exact same waveform. They're offset slightly because of some DC shift or something. Pin 4. It's near identical. Pin 5. That says 16% difference. Let's see. What is this? I've lost count. 1, 2, 3, 4, 5, 6. Looks the same. 7. I'm looking for a big difference. Or maybe it won't be a big difference. 8 is ground, I believe, yeah. Pin, where's 9? That's not 9. That's 9. Yeah, it shows 10% difference. But generally the same shape waveform. Looks like there's a fair amount of capacitance on it. 8, 9. Is this 10? Yep. Looks good. Pin 11. So a straight line looks like just some resistance or something. 12. A little bit of a knee there, but identical. 13. Same waveform. 14. If I can get on there. 14. 20% difference. 18. It varies a little bit. It's the same shape. It's just a very slight knee you can see there. Not sure how well that shows up on camera, but like I can show you. Like, here's one. You see the red line going vertical, and if I get on, this is the yellow channel. They're landing on top of each other, which is what they should do. You know, if there's no difference. It overlays them. I have not swapped out the PFC transistor. Oh, you did see the video. Okay. PFC TX, Steve. You mean the transformer or transistor? I mean, I definitely have a PFC transistor I could swap out. Transformer, I'd probably have to steal one off another board, which we can do. There's not that many connections to a PFC transformer. I'll have to steal it off this other one. Why not? Why not? There's only like 4 solder connections. Yeah, I've shown this thing before in some earlier videos. Some of you may not have seen it. And it came, I added these feet to it, these little flip out kickstands, because I needed something to hold it at just that angle, because it would just lay flat, or I'd have to prop it on some solder or something. So I got these off eBay. I think it's like for a cell phone or something. But kind of a nice added feature, make it a little more useful for me. All right, I'll tell you what, we'll swap out this coil, because at this point, that's the only way we're going to know. Because it could be something about it breaking down under load. Now, what I'm going to do, before I take this off, this is our good one. See the check mark? I'm going to put a check mark on this transformer, because I do not want to get them mixed up. Like I said, this board here is running solid, stable, no issues. All righty. Let's remove this thing without damaging it, without damaging the board if we could. Yeah, I don't really have a lot of PFC coils laying around. I may have a donor, maybe, but I think I'd rather, for science purposes, we're just going to take this one. Yeah, this is a working supply. I've got to untangle my cords here. This is a working supply. So, not really. This is just for learning. But then again, a lot of the things I do is for learning. You know, kind of gets to be, is this supply worth spending hours and days trying to fix it? Probably not. But by doing that, the next time I encounter a problem, it won't be hours and days. I'll recognize it. So that's kind of my theory on, some of the time that I spend on. And I'm very fortunate that I can do that because I'm just a hobbyist. I'm not having to do this to feed a family or keep a roof over my head. It is for the fun of it. And in my day job, I don't really get to do a lot of component level troubleshooting. So I kind of have to. Oh yeah, she's falling right off. Have to have my fun this way. All right. Yeah, just 4 connections, because it's not a transformer; it's just a coil. This leg's not. It's just a mounting leg. There's nothing. There's no wires hooked to this leg. Your main leg is here and here, and this is just a shield. It's a ground. There's a coil, a copper foil layer wrapped around it for shielding. I guess trying to keep some of the noise it spreads out off. Keep that at minimum. But there's this here and here. I'm not sure what the inductance of this thing is. Never checked it. Let's check it. Which will probably vary depending on which frequency you use. Let's see. My goodness, the dust on the screen. Of course, I'm normally checking capacitors of this thing, so I'll have to switch it to inductance. Set up function A. No. It's been a while since I've used this thing. Set up. There we go, function A. Oh, yeah, and I did notice the soft keys here where it says, see there, all right, there's inductance. All right, battery's at 40%. Need to charge this thing, I guess. Measure. What do we get? 150 microhenry. That's at 120 hertz. Let's raise that frequency on up, because this thing is not running at 120 hertz in the circuit. Where is my test frequency? 10 kilohertz. That's as high as I can go with this little tester. Measure. 149.58. So it's a roughly 150 microhenry coil. Yeah, I don't have 100 kilohertz. I'm sorry. It's just a little cheap one. Yeah, it will check caps for ESR up to 10 kilohertz. I think these people may make a model that goes up to 100 kilohertz, but I bought this used off eBay years ago. It's been pretty handy for checking the health of capacitors. I don't really check, and it does have a 4-wire connection for checking resistors as well. Anyway, so roughly 150 microhenry. I need to remember to charge that. It doesn't seem to self-discharge very much. It'll sit there on that shelf for months. It always turns back on. So it doesn't self-discharge. All right, this is our good one. Let's move on. Give it a little encouragement juice here. Flux. I do have a solder sucker for these through-hole components, like I mentioned before, a Hakko. But by the time I crawl onto the workbench to get this thing plugged in, I could have had this off. So that's why I don't, you know, if I had a 14 pin or more IC to replace, I would be breaking it out. But literally, this is 4 legs, and it's out, complete with roach poop, all up in the windings. All right, so I mean, we'll just, you know, I'll swap them fully. We'll put this one on the other one. So here's our bad board. Good PFC. Let me clean some of the undesirable stuff out from under. This thing was did have some roach infestation going on. Not as bad as some that I've seen. Nowhere near as bad as some that I've seen. All right, let me get this turned the right way. Can't really get it wrong though, because this leg is offset. And there's offset holes. There we go. Now, if we have to swap out this other, coil, the one for the 12 volts, that's a bit of a fight. I've done it. I use low melt solder for that. Because there's a lot of pins. And on the output side, there's pins with a lot of mass to them. All right, coil is in. I think I got it down on the board nice and flat. Just set that to the side. All right, let's see what it does. Excuse me. Pardon me. I'm not 100% recovered from strep throat yet. Where are my leads to my dummy load? Right here. Under everything else. Positive. Negative. And let me get my meter. Wake up meter. Oh, come on, clip that on there. So we are metering our PFC voltage. AC cord. All right, let me put that little camera back up so you can see the load and stuff. All right, we're up and running. 395. All right, let's start winding it up. $10 amps, still looks good. 11, 12, 13. Nope, I saw a little flicker there. Well, maybe not. 14. We're getting nervous. 15. Now we're getting nervous. 411. I'm sorry. There's 17. There's 16. Yeah, see, we're 415 volts there. 17. 18. Oh, I can't count apparently. I'm turning and just counting and I'm not really looking at the dial. That's 21 amps right there. 22, 23, 24, that's 25. It seems like it's jumping here. 26, 27, 28, 29, 30, 31. Yeah. 31, it likes to jump up to 417 volts. So no change, I would say. There's 17 amps. She's still jumping up to 417 volts. Five amps, solid. Okay. And like I said, both of these capacitors have been replaced. Both of the capacitors. The reference voltage, it bounces around also as that voltage is changing. Of course, when I put a meter on it, I'm influencing it slightly. We can look at it. I did not replace them again. No, these are brand new out of my package, out of the drawers up there. But yeah, I have metered that PFC feedback voltage, which should be 2.5 volts. And it jumps along with the output voltage. Let me see the easiest way to do this. Unplug it, because I've got to flip this over. Of course, our caps are still charged. Oh, I need to, sorry. I can stick my my leads for my load back in from the back side, luckily. All right, I will meter that feedback. And I believe it's best I can recall, it does reflect, what's actually happening. All right. And even though this is like a 10 meg ohm input impedance, it does influence it a little. Like right now we're still at 5 amps. And I'm going to get on pin 2. I'm trying to think of I may get on it. I hate to get on right on the chip because there's a chance I'll slip. So I was thinking I'll just come back to a more convenient point either on this Zener or right here on this resistor right there. Oops. Did I yeah. That seems high. Ooh, I don't like doing that. It does influence it. Let me get right on pin 2. I don't remember it being. See, it's nervous there. And see the output voltage is varying. Running a little bit high. Should be right at 2.50 usually when I see it. I have not replaced the divider resistors. The two 7.5 megs. Now, if you're wanting me to, this is kind of precarious. I'll turn this up now. $11 amps. Man, that voltage is nervous. $14 amps. 15 amps. That feedback voltage is nervous. 16 amps. 2.4 to 2.6 on that feedback voltage. Bring this back down to 5. And it still seems it's nervous there. But then again, I think my meter is influencing it. Like, see it bumping over 400 volts there at 5. But if I take my leads off, I think you'll see that settle down. So my meter is influencing it. So I'm interjecting noise there. And I'm putting 10 megohms right across that, 100K, 95K resistor. I'm influencing it a little. My audio is cutting out. Uh-oh. My microphone shows it's still working. I was afraid my battery had died, but it's still... Okay. Other people are not having any... I'm sorry, I keep coughing. It's a habit I have right now. Audio is fine? Okay. But yeah. See, it'll sit there and run rock solid at 5 amps. It's just at certain places... Okay, it was on your end, Steve? Okay. At certain places... Let's see, can I switch to that? Give me a moment. 400. This is what we're talking about. We're metering. Here's where the boost voltage is across those capacitors. It should be 395. Goes through these two 7.5 megohm resistors. There's a 95.3K to ground. There's a Zener, which I did swap that out yesterday. Small 560 picofarad capacitor into pin 2. That is the chain. That's how it gets to the. This is where that 2.5. This is where I was measuring 2.5 volts. And there's this MOSFET down here, which is part of a shutdown circuit. I did replace this yesterday. Swap this out. Yeah, I made this schematic. So there's not a whole lot more to the PFC circuit. We replaced the coil here. I have not replaced the MOSFET. There are quite a few capacitors, that could be breaking down. It's a weird one. It is quite odd. There's not that much to the PFC. And what I've been trying to figure out, though, is the problem with the PFC circuit, or is it, the output load? Is there a problem with that circuit, with the 12-volt circuit? Because the PFC voltage has to be adjusted constantly because of the changing load. Is that the problem? I don't know. But, looking at the output, the 12-volt output is rock solid. It doesn't seem to change at all. Yeah, it's done in KiCad. It is done in KiCad. I have done the 400 DR, ER, FR, GR, and the 420 DR, which is for the Pro. I don't know. So, well, I don't know I can't remember on this one what the original fault was. Because when I got it, it was missing components. But I want to say there are some parts that have had a flashover. There are some parts. Let me see if we can. Let's see if we can switch to. Don't I have a microscope with corner? Yeah. Let me unplug this thing. And there was a flashover, and I thought about, you know, it could be some capacitors that you know have seen more voltage than they should have, and now they are erratic. I'm discharging these capacitors. We're not getting bit today. And so this thing, this discharge tool will get them down to about 3 volts, 2.5, 3 volts, and then it kind of really slows down. So that's why I'll come back with this tool and just short it. Because at that point, there's nothing left. There were some places, where was it? Where obviously, right in there you can see us. But that is directly, though, I looked at that yesterday. That's directly across the boost voltage. So it's not like it's going to something that wouldn't, it's going to ground. That's 395 going to ground is what happened there. Some poor roach stepped there, and that was the end of it. But that wouldn't take it, you know, it's not like it went to a low voltage circuit. It went to ground. And I don't remember if I saw another place. So there's those two 7.5 megohm dividers. And they look just beautiful. I can swap them, but it's just hard for me to believe that they're doing a perfect job at 5 amp of load, but not 16 amps of load. You know what I'm saying? And there's the current samples for the PFC right there. That's what it's looking at. Because I got to wondering, well, is it because of the PFC circuit detecting loading? You know, some weird loading or something. It senses, this chip senses the boost voltage on pin 2, and it's sensing the current draw on pin 3. Did I see another, right there's a bit of a scorch mark. That is on one of those transistors that was removed. I've replaced it. Yeah, there's been a little bit of something going on in that area. This is underneath the transistors for the 12 volt circuit. Has been a little something going on there. Is that in focus? I was trying to see if it's coming out in focus. So yeah, that's seen something, but it doesn't look damaged other than discolored. Those are 10k ohm resistors there from the gate to the source on the MOSFETs. They look healthy. I could change out the output transformer. For science, of course. Like I said, these opto-isolators have not been touched. Those are originals. That looks right. I think the only one that's really critical on these opto-isolators is going to be this middle one. That's the one for your correction voltage. These other two are actually kind of being used as on-off. They're either hard on or hard off. They're not really using the fine, current transfer ratio of those things to do any kind of regulation. That middle one is. It is load dependent. Yes, it is, Orion. And I thought I had it fixed, but I was looking at the wrong one. This could be the one that beats me. It could be. Oh, bare careful on the board. Yeah, I mean, no, I don't think we're having any leakage issues, any kind of creepage or anything like that. I really don't. Anyway, how about since I'm live streaming anyway, let's swap the output transformer. I wish I had one just laying around so I could swap it in there in a hurry, but I don't. All right. So let me mark. This is our known good transformer. We'll give it a little red check mark there. I'm just curious. I don't want to damage that. I am curious as to what this is. And unfortunately, there's no easy way of doing this. This output transformer has a lot of windings. On this output side, they're large. I'll have to use some low melt over there to ever get that off. I might could use some solder braid on the input side as soon as I find it. Oh, here it is. It made its way across the bench somehow. I'll try just to wick these. But yeah, this is the one from yesterday that was unstable at certain currents. 5 amps, it was fine. 10 amps, it was fine. You started getting like 15, 16 amps, and it got very nervous. The PFC voltage got nervous. Now the output's still working fine. It's still putting 12 volts out like nothing. And I don't think it even varied any. The output did not. But that PFC voltage varying around like that, shooting up to, it never went into to the danger area. You know what I'm saying? It didn't go to 450 volts or, you know, nothing exceeding the voltage of the capacitor. But it should not be nervous like that. It should really just sit there at 394, 395, 396 and you know, maybe vary a volt. Maybe. Did I get all those? Can't tell. Come on. There we go. Now this, I always use a little bit of low melt, because wicking those big old contacts clean. Because they're actually, these contacts on this side are actually just, they are twisted wire coming out of that coil, out of that transformer. It's not like it's a solid, you know, piece of leg of copper. It's braided, or, you know, copper, twisted. I don't know how many strands it has, but it's stranded copper wire. That's what I was trying to say. So I'm going to heat this, add a little low melt to it. And if I'm lucky, try not to damage anything. I'll get in with a screwdriver so I can just apply a little bit of pressure. If I can get it in there. Well, not wanting to cooperate. Huh. This one seems to be closer to the board than they usually are. Okay. I can't really get a good pry on it. I can't get any pry on it. How about out here? It's just like really, the body of it is like really close to the PCB. I think I barely got under there that time. All right. Now, since I've added that low melt to these pins. I'm just going to heat this up. Kind of go back and forth. And I lost my pry. This is rather time consuming, not something you want to do regularly. It's for science. That's the only way I know to eliminate the output transformer. Because I have had one of those fail on me recently. But it didn't fail like this. It wouldn't run. The system would start, it would give a few pulses, looking over the scope, watching the drive to the gates of those output transistors. And then it would give up. I mean, it was like 100 milliseconds maybe, and it just gave up. So, if this is a transformer, it's much more subtle. Okay, I don't have my input side totally lifted like I thought I did. Don't want to damage the pads or anything. What did I miss? I see a little bit of solder right here on this pin. Is that it? Oh, now we're coming out. Now we're coming out. Let go. There we are. Now what I'm going to do is go ahead and try to remove as much of this low melt as I can from these legs. Hello, Dan. Welcome. Oh, leaky cap? Yeah, it's possible. The leaky cap's going to be hard to find also, so that's not probably going to show up on a capacitor checker unless you've got one that can, stress test it, put a few hundred volts on it or something. But that's what's kind of weird about this is an instability with a load. It's not like the voltage is changing, the output voltage or anything like that, or it's just weird. So this is a learning experience. Just trying to get off as much as this low melt as I can. The low melt is great for removing stuff. It's horrible for holding stuff on your board though, because it's so brittle. Anyway, let me look under the microscope a second. I'm going to show you what these legs are made out of. See, it's the actual braided wire coming out of that transformer. Rather high current. This thing is rated at 31 amps. It kind of needs to be. I don't want to flare these out too much because then they won't go in the holes. Let me get rid of that one little stray strand I see. So this is our good one. Yep. All right. All right. Here is our donor. Now we got to do the same thing over here. Where's my flux? In the flux holder. All right. All right, I think I have those pretty clean. This one's going to be a little, it's going to be disgusting on the bottom edge of it because this is the one that has the, this is the roach infested one. It's not going to be too pretty under here. And she falls off. Not too bad. There she is. Well, let me get rid of this low melt. Okay. Did I get something on the capacitor? Yeah, I got a little extra solder on the end of C141 there. Okay. I got it cleaned up though. And we are ready to install our donor. I'm just going to clean it up just a little. But probably pointless because I'm about to put flux back on it again and make a mess again. Alright, good one with the mark on it. Different color. Oh, let me clean. There is some nastiness up under here on the board. Look at that. Let's clean that up a little. A little discolored there. Circuit board's a little discolored. Right around that one leg. Let me show you under the microscope. A little discolored there. And also, I did remove this capacitor right here. Also, this is a very important capacitor. This big black one right here. But it checks just fine. It's 82 nanofarad, I think it is. I guess I got flux all down in those things. And those holes. All right, enough of that. And this is our good one. There we go. Slid right in there. Tack one on the other side here, so we can't just fall off. There we go. I'm just about out of my larger solder here. Got a lot of the smaller stuff. I think I have another roll though, somewhere. Okay. Let me give this a little bit of a clean since I've gotten flux everywhere. All right. Don't think I shorted anything. Try to make sure I didn't splash any solder anywhere I shouldn't have. All right. Is it going to act any different? Probably not. But at least we eliminated something. Plus, minus. Put this low melt up before it rolls up onto the board and shorts something. Alrighty, where's that? Let's see. Make sure there was nothing under there. Oh, popped right off. 5 amps of load. Let's see if we will at least run. And we're running. All right, we seem to be stable at 5 amps. $10 amps. So far so good. 12, 13, 14. Nope, there's 14. Look at it getting unhappy at 14. 15. 16. Very unhappy. So no, I'm going to say the transformer did absolutely nothing. It's not the PFC coil, it's not the transformer. Nope. Something is, I tend to think something is breaking down. Hello, David. I'm well. I'm just frustrated. A little bit frustrated right now. This power supply is kicking my butt. Okay, so you only got 268 volts across it. I'm running out of ideas. Okay, we're safe now. We are safe. Tell you what, I am curious. I want to put a TEA 2016 in here. Just want to see if the behavior changes in any way. Probably not. This is one I've used somewhere before. Okay. Just want to see if it behaves any different. Make sure I didn't put it in there backwards, which I've done before. That looks correct. You can tell that the angled shoulder on that chip. And there's a circle there. But there's a beveled edge to it on the side that has pin 1. In theory, this should make no difference whatsoever. Much like everything else I've done to this power supply. Okay. Plug it in. And we start and we run. Five amps. 6, 7, 8, 9, 10. Nope. She's unstable at 10 amps. I can hear an audible noise from one of these transformers. Ooh, ooh, ooh. I'm hearing an arcing noise. It sounds like arcing. So it's worse with the TEA 2016. That's at 10 amps and she's nervous. Not sure if the mic is picking that. Let me turn this fan off. I'll put my microphone down here. Not a very friendly sound there. Did that come across too well? It does sound like arcing. I wonder if it's visible in the dark. It sounds a little bit to me like the windings of a coil, vibrating. Let me try. I'm going to turn off some lights. I don't think I'm going to visibly see anything. Bear with me here. We are still running right now. Oh, my lead popped off. My lead popped off and it's dark. I don't think this mic is directional enough to help. And I hate getting my ear down here this close. I need toilet paper tube. Still can't narrow it down. I think it's coming from the PFC coil itself. That's where I think it's coming from. That's what it sounds like. Which of course is a known good coil. Oh, excuse me, I got a cough. It sounds kind of like an arc, but I just don't know. I don't know what it is. I mean, these transformers will sound weird. $400 volts. That's 16 amps. Very unhappy. PFC MOSFET itself? I doubt it. I doubt it. But I tell you what, I'll change it out though. Instead of sitting here listening to this thing fry. I don't think it's arcing. Oh, come on. I'm trying to get one of my lights plugged back in. Work with me here. There we go. All right, I'm going to change the PFC MOSFET. I don't think it's it. running out of ideas here. Again, I've lost my solder wick. It's here in front of me. Need to update the firmware on this thing. Where's the solder wick? Well, I'll just grab another roll of it, because that one seems to have disappeared. Okay. We can do that. That will ensure the other one shows up suddenly. I dropped it in the floor. All right, I'm going to desolder this PFC MOSFET. It is somewhat interesting, though, that putting the 2016 in there made the instability worse. Okay. Screwdriver. Pliers. I'm going to have to transfer over, oh come on, the ferrite beads as well. Well, there she is. Could use a little more thermal compound on the back. And I do have these exact same transistors. 40N60M2. Okay, I need my hot glue once again. Still wondering where that solder wick went. As far as testing this, I mean, you could test it for, you know, being shorted or not, which it's not shorted. But you really can't test it to see if it's breaking down at 400 volts or not. Not readily available. I need to put some thermal grease on this as well. Yeah, I'll wait to put that on there until I get these ferrite beads stuck down. It's just gonna be, that stuff is messy. It gets everywhere. Waiting on my glue gun to warm up. That solder work will show back up. Yeah. Oh, wait, here it is in the floor. I found it. In the floor. I need more glue. More glue. Oh yeah, here it is. Getting rather warm. I'm just trying to get this glue to soak in there and adhere really well to that bead. Okay. Move the glue gun out of the way so it can spit glue every place else. As I know it will. Come on now. Get. Okay, can I get you started? Okay. Just a quick clean. Let's see what happens. I am not confident at all. We are. We're set for 9 amps. Don't go boom. She started. Nope. Ooh. Very unhappy at 12. Nope. Nope, nope, nope. Not happening. Yeah, and we're making bacon again. Not good. The most likely thing is something breaking down. But I don't know what. There are, of course, a lot of tiny capacitors scattered everywhere. I don't know. I don't know. Right now, it's a bacon making machine. Yeah, I do have a big Thanksgiving planned. Thank you, David. We'll be having the family over, and I'll be cooking. Well, hello, Sarah. Good to see you. Sneaking in. Anyway, this is I'm getting some burnout from this, so I'm going to take a break, and I may pick it up again. So, sorry it wasn't a fix. I thought I had a fix. That's why I was going to stream, show you how I fixed it, and then I realized I had picked up the wrong board. So, failure is an option. But all right, I'm going to hop off. Y'all can see if Joey's still streaming or something. I'm going to take a break and check my sanity for a while. But thanks for coming by. I haven't totally given up yet. I have not totally given up. But I do appreciate you all coming by and at least struggling along with me here. Thanks, Russ. Thanks. Peace, guys. See y'all later. Been fun.